Lesson 6, topic, geometric proofs, part 1, learning target, I can write proofs using geometric theorems. First off, some key terms. Proof is a logical argument that shows a statement is true. Two-column proof, that's going to be the form we'll write our proofs in, gives numbered statements and corresponding reasons that show an argument in a logical order. And lastly, reasons we can use in our two-column proofs. So reasons used can include definitions, properties, postulates, and theorems. So let's practice. Let's complete this proof. Given AC equals AB plus AB, show or prove that AB equals BC. First off, let's make sense of this. Given AC, so AC is this length. And we're saying that it equals AB plus AB. So we're saying it equals 2 of this length. So if AB equaled 7, well then AB plus AB would be 7 plus 7, which would mean the whole length would be 14. We also know that because this is collinear points, B is in the middle of A and C, we also know that this length AC is going to be equal to AB plus BC, which means that BC should also end up being 7, which then would be that AB equals BC. So logically, we can make sense of that using numbers, using reasoning in our head, and then that proof is, hey, let's write this out in a logical order. Let's use numbered statements and corresponding reasons to show why this is actually true. So that's what a proof is. So that's what we're going to do. So we always start off with our given, because what we're given to start our proof. So we have AC equals AB plus AB. And then as I said, we know that AB plus BC equals AC by that segment addition postulate. So we reviewed that last lesson. You can go back to lesson 5 and review it if you need to. Then the next piece, let's look at this, is AB plus BC. So if you see that is in purple, so I would look here at this purple. And then equals AB plus AB. Well, that comes from here, AB plus AB. So how do we use parts 1 and 2 to make 3? Well, you can see that both the pieces I've boxed are equal to AC. So we have that crisscross. We have two things equal to the same thing, meaning that those two things are then equal. You remember from last lesson, that's that transitive property of equality. States if two things are equal to the same thing, then those two things are also equal. So there's also that crisscross pattern. These two are the same, so that means we can set the other two equal to each other. Then let's look at statement 4. We have BC equals AB. So if we look from 3 to 4, how did we get to just BC and AB? Well, I see that I have an AB on each side, so I could subtract AB from both sides. And the reason I can do that is the subtraction property of equality. And then lastly, we just flip-flopped AB and BC to the other side of the equal sign. And the reason we can do that is our symmetric property of equality. So we were given AC equals AB plus AB, and we showed that AB then equals BC. All right, so just a reminder of those reflexive, symmetric, and transitive properties. We talked about this in lesson 5. We just had a couple examples in our proof. But those are the 3 properties. Last one, we focused on the properties of equality, and now we're bringing in that fact that it can be used for congruence of segments and congruence of angles as well. So reminder, reflexive just means anything is equal or congruent to itself. We know angle A is congruent to itself, angle A. Symmetric property is if two values are equal or congruent, they can be flipped to opposite sides of the equal sign or congruence symbol. So if angle A is congruent to angle B, then angle B is congruent to angle A. We can do that flip-flop. And then the transitive property, if two different values are equal or congruent to a third value, the two values are equal or congruent. So if angle A is congruent to angle B and angle B is congruent to angle C, see angle B is in both. So then the other two, angle A is congruent to angle C. So for each example below, name the property illustrated by the statement. So we have the statement, segment CD is congruent to itself, segment CD. Congruent to itself means we're using that reflexive property. The next one, if angle R is congruent to angle T and angle T is congruent to angle P, we see angle T in both. So that means angle R is then congruent to angle P. That's that transitive property. And lastly, we have if segment NK is congruent to segment BD, then segment BD is congruent to segment NK. All we did was flip-flop. So that is your symmetric property. All right, so now that we've reviewed those, we can move into our last example. Example 2, prove this property of midpoints. If you know that M is the midpoint of AB, prove that AB is 2 times AM and AM is 1/2 AB. So if we know that M is the midpoint of AB, we know by definition of a midpoint, that's cutting it into two congruent segments. So we know that AM and MB are then going to be congruent by that midpoint definition. And we want to show that AB, so this length right here, is equal to 2 of AM. Well, let's say AM is 4. That would mean that MB is also 4, and that would mean that the whole entire length would be 8 by that segment addition postulate, 4 plus 4 equals 8. So does that hold true? AB 8 equals 2 times AM, 2 times 4? Yes, it does. And AM, 4, is equal to 1/2 of AB, 1/2 of 8 is 4. So logically, this should make sense in our brains. We should understand the concept behind it. And then now we just want to write it out in those logical statements and corresponding reasons. So again, the statements have been given for you. You just need to find the reason. So M is the midpoint of AB. That was given to us right here, given. M is the midpoint of segment AB. AM is congruent to MB. Well, if we know something is a midpoint, we know it cuts it into two congruent segments. So that is just your definition of midpoint. So a lot of times I always like to look for the key vocabulary words in the sentence and then think about the definition and if I can use that definition. And since we can use the definition, we're going to use it. The next piece, if you look from number 2 to number 3, all we did was change it from congruency to equal. So instead of talking about the segments being congruent, we're talking about their measures being equal. And that's just the definition of congruent segments. And the reason we needed to jump from congruency to equality is because our proof, what we need to prove is inequality, which means we do have to make that jump. We have to make that switch. Now we have AM plus MB equals AB. So I'm going to go back up to the diagram, and AM plus MB, these two added together equals this whole thing. And remember, if we do that, that's the segment addition postulate. Now, if we look from number 4 to number 5, what changed? Well, AM stayed the same plus, MB turned to AM and the AB stayed the same. Well, why could we replace MB with AM? Right here in number 3, we're told that their measures are equal, which means we can replace one with the other or substitute. So that's the substitution property of equality. The next one is we have 2AM equals AB. So we look at part 5, AM plus AM. We can add those together to be 2am. So that's just combining like terms, simplify. And lastly, how do we go from part 6 to part 7? Well, 2am equals AB. If we divide this side by 2, we'd get rid of the 2 there. Divide this side by 2. Another way of writing that would be 1/2 AB. So AM equals 1/2 AB. And that's just by that division property of equality. I apologize that this video was so long, but go ahead and move into your practice.